Greetings, everyone. The topic of our video today pertains to a remarkable breakthrough that enables the degradation of stubborn, forever chemicals found in our water supply. Pioneered by a University of Missouri researcher, this technique harnesses ordinary materials and moderate heat to transform these industrial pollutants into harmless byproducts. Such innovative developments hold the promise of safer communities, reduced health risks, and a healthier environment. Without further ado, let us delve into our discussion. Per- and polyfluoroalkyls, referred to as PFAS from now on, are industrial chemicals used in the creation of countless items. This includes cosmetics and carpeting, plus non-stick cookware. It also includes stain-resistant fabrics and firefighting foams, as well as food packaging and waterproof clothing. They have spread far and wide like silent stowaways that creep into our surroundings, our food, and ultimately our bodies. Peer-reviewed studies have concluded that PFAS exposure may result in decreased fertility, developmental delays in children, and an increased likelihood of some cancers. For almost the past 10 years, researchers have sought methods to remove these forever chemicals from our environment, or at least transform them into harmless inorganic compounds. These substances, ironically, can endure for hundreds or even thousands of years. Meanwhile, a University of Missouri researcher has revolutionized the fight against PFAS by discovering a simple technique to remove them from our drinking water. Now, Frank Xiao, an associate professor in Mizzou's College of Engineering with his team, has uncovered a low-cost remedy using common materials. You don't need organic solvent or really high temperatures, Xiao, whose specialty is degrading PFAS, said. Just heat the PFAS with granular activated carbon, or GAC. Indeed, GAC is made up of carbon-rich materials that have been heated, coal or wood, for example. Consumers already use it to filter household aquariums or cleanse drinking water, and it can be purchased online for only a few dollars per pound. In a study recently published in the journal Environmental Science and Technology, the team detailed how heating PFAS with common GAC at 572 degrees Fahrenheit produced 90% mineralization, converting these seemingly eternal chemicals into harmless inorganic fluorine. Prior attempts demanded temperatures surpassing 1292 degrees Fahrenheit, high pressure, or solvents. Xiao's approach significantly lowers costs and increases sustainability. Because GAC remains inexpensive, it can be reheated multiple times. The key, Xiao explains, lies in the union of GAC and heat. Once GAC is involved, the thermal degradation of PFAS occurs much faster, and the mineralization is more intense, Xiao said. Reverse osmosis, though effective, can be costly or complex. This new method can be carried out locally in a typical furnace. It is far more accessible. For farmers and communities grappling with PFAS-laden solid wastes, biosolids and spent adsorbent media, this invention stands as a major breakthrough. In the Midwest, herbicides and pharmaceuticals can be loaded with these compounds, plus the environment suffers as a consequence. Now, we can drastically lessen the presence of PFAS. Xiao credits Mizzou for the collaborative research environment, especially noting that undergraduate and graduate students share his devotion to safeguarding water quality and the ecosystem. He conveys to those students a fervor for pragmatic engineering research and the opportunity to better the world. The real-world application of this discovery is that we can effectively and efficiently remove forever chemicals and other contaminants from our water, he said. This is the technology we need. To support our channel's growth and ensure broader awareness, kindly hit the like, share, and subscribe buttons. This will help us reach more individuals and disseminate valuable information. Thank you in advance.